Hello and welcome to another GCSE revision video, and this video is on probability and we're looking at independent and dependent events. Independent events are when two or more events have no effect on each other. For example, tossing a coin 5 times in a row will not affect the outcome of the 6th toss. Okay, that may sound obvious, but there is a mathematical concept called the Gamblers Fallacy, where people mistake independent and dependent events. The Gamblers Fallacy is the belief in a hot streak or a losing streak, where independent events are wrongly believed to be dependent. An example would be, the odds of me throwing a 6 on a fair die is 1 chance in 6, but the last 5 throws did not fall on a 6, so the law of averages owes me a 6. This is wrong. The chances of me throwing a 6 is still 1 chance in 6, regardless of what happened in the previous throws. Okay, a fair coin is tossed high in the air 100 times. The last 99 times the coin landed on heads. So what is the probability that the 100th coin toss will land on heads? Well, if you said the probability is 0.5 or 50% or a half or 50-50, then you would be absolutely right. The previous 99 times are irrelevant. They do not affect what happens on the 100th coin toss. The outcome of the previous 99 events do not matter. The law of averages owes you nothing. Now, dependent events are where the results of a previous event do have an impact on future events. For example, a box is filled with red and blue sweets. There are 5 red sweets and 5 blue sweets. Now, what is the probability of picking a blue sweet at random? Well, there are 5 blue sweets, which is our event, out of a total of 10 sweets, which is our sample space. So the probability of picking a blue sweet at random is 5 out of 10, or 1/2, or 0.5, or 50%. Now, a box is filled with red and blue sweets. There used to be 5 red sweets and 5 blue sweets, but Mark picks a blue sweet at random and does not return it to the box. Now, what is the probability of picking a blue sweet at random? There are now 4 blue sweets, which is our event, out of a total of 9 sweets, which is our sample space. So the probability of picking a blue sweet at random is 4/9, or 0.4444 recurring, or 44.444%. Okay, a box is filled with red and blue sweets. There were 5 red sweets and 5 blue sweets. Mark picks a blue sweet at random and does not return it to a box. The next 3 children pick a blue sweet at random and do not return them to the box. Now, what is the probability of the next child picking a blue sweet at random? Okay, there were 5 blue sweets. 4 have now been taken, leaving just 1 blue sweet. But nobody has taken any red sweets, so there are still 5 red sweets. So there is 1 blue sweet, which is our event, out of a total of 6 sweets, which is our sample space. So the probability is 1 out of 6, or 1 over 6, or 0.16667, or 16.66667%. Okay, so what if the 5 previous children have all picked blue sweets at random? Now what is the probability that the 6th child will pick a blue sweet at random? So there are now no blue sweets in a box containing only red sweets. So the probability of picking a blue sweet at random is 0, which is our event, out of 5, which is our sample space. So the probability is 0, zip, zilch, nada, impossible, don't be silly, how can you pick a blue sweet out of a box filled only with red sweets, or words to that effect. Okay, so much for the theory. Let's have a go at putting this into practice. In order to decide who goes first on a board game, my friends and I all roll a fair die. The first to throw a 6 gets to go first. Peter rolls a 1 and Jane rolls a 4. Jasmine rolls a 3 and Robert rolls a 2. What is the probability that I will roll a 6? Well, the first thing we have to do is ask ourselves, is these probabilities dependent or independent? Well, in this case, the die just doesn't care what the previous rolls were. There's still 6 numbers on the die. Those numbers don't change because other people have rolled the numbers. So they're independent, and therefore the chances of me rolling a 6 is the same as if I'd gone first. It's just 1 in 6. There's one number 6 on the die, which is our event, and there are 6 possible numbers, which is our sample space, so my chances are 1 in 6. It doesn't matter what Peter, Jane, Jasmine and Robert rolled. Okay, let's have a look at another question. Okay, Jane is given a box of chocolates, but she has lost the key. The box contains 4 caramel centres, 2 coffee centres and 4 strawberry centres. Jane hates coffee centres but likes the others. Yesterday we calculated that the probability of her picking a chocolate that she likes is 8 out of 10 or 80%. Yesterday Jane ate a strawberry centre by random chance. What is the probability that Jane will pick at random a chocolate that she likes? Okay, so again we have to ask ourselves, is this probability dependent or independent? Does it matter what she had yesterday? Well, in this case, yes it does, because she's eaten a strawberry centre yesterday, so there is now 1 less strawberry centre in the box. Now, it might be tempting to say, okay, so there's 1 less strawberry centre, so instead of 8 out of 10, the probability is now 7 out of 10. But that would be wrong, because there are now only 9 chocolates left in the box. So our event is 4 caramels plus 2. Sorry, we don't want the 2 coffees. We now no longer have 4 strawberries, we have 3 strawberry centres. So that's 4 plus 3 out of a total of 4 caramels plus 2 coffees plus there are now 3 strawberries. So that's equal to 7 out of 9. Okay, I hope that was helpful, and I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in a future video.